afternoon, everyone. Let me start by welcoming you on behalf of the Canadian Science Policy Centre. My name is Christian Basila, and I will be your moderator this afternoon. Before I go any further, I want to take a moment to acknowledge that Tiohtià:ke, commonly known as Montreal, is located on unceded Indigenous lands. The Kanien'kehá:ka Nation are recognized as custodians of the lands and waters on which some of us gather today. A few housekeeping notes before we get going on our main topic of the day. Please note that the panel is held in webinar format and that as the audience, you are not visible. Your mics and cameras are turned off. We ask that you use the Q&A feature in Zoom for your questions to the panelists. The chat line is available but should be used only for communicating issues with the organizers. Finally, you can upvote a question that you would like answered instead of repeating that same question if you do see it in the chat. So today's topic is Canada's quantum strategy and international collaboration. Our panelists will discuss opportunities and challenges Canada will be facing and what this could mean for Canada's leadership in quantum research and development of quantum technologies. Our dynamic panel is made up of 5 important contributors to the quantum ecosystem in Canada, and we're delighted to have them share a perspective with us this afternoon. I will start with Dr. Amy Gunther, who is the Deputy Director of the Internet of Things, Quantum Sensors Challenge Program at the National Research Council of Canada. At the NRC, she also engages across research centers and collaborative challenges programs to shape and lead the quantum communications theme within the High Throughput and Secure Networks Challenges program. Welcome, Dr. Gunther. Our second panelist is Professor Andrea Damascheli, who is a full professor at the University of British Columbia and a Tier 1 Canada Research Chair in the Electronics Structure of Quantum Materials. He currently serves as Scientific Director of the Stuart Blouson Quantum Matter Institute at UBC and is co-director of the Max Planck UBC U-Tokyo Center for Quantum Materials. Our third panelist is Dr. Sarah Burke, who is an associate professor in the departments of physics and astronomy and chemistry at the University of British Columbia. She is a principal investigator at the Stuart Blouson Quantum Materials Institute, where she also serves as a member of the leadership team. Her research uses scanning probe microscopy techniques to investigate materials at the atomic scale-up. Our fourth panelist is Nick Westrick. He is the Chief Executive Officer of Quantum Valley Ideas Labs, leading the strategy and growth of the Applied Quantum Research Lab based in Waterloo. He previously served as Director of AI Offerings at IBM, where he led an AI product portfolio and IBM Spectrum Computing, driving a large spectrum of products in HPC, AI, and cloud-based services. Our fifth and final panelist is Mr. Eric Miller, who is the president of Rideau Potomac Strategy Group, a consultancy that advises companies and governments on science and technology policy, economic affairs, and geopolitics. He has been providing advice on quantum technologies and strategy to a number of Canadian entities, including Innovation, Science and Economic Development Canada, the National Research Council, and the Embassy of Canada in Washington, D.C. Eric is a fellow of the Canadian Global Affairs Institute, a global fellow at the Canada Institute of Woodrow Wilson Centre, and a fellow with the Future of Business Centre at the Canadian Chamber of Commerce. With this, I would like to welcome, ladies and gentlemen, everyone to this panel, and I will thank you for your time today. As you know, the topic of the discussion is centered around how Canada wants to position itself at the forefront of quantum computing, quantum sensing, and other quantum technologies. In recent budgets, the federal government has allocated $360 million over 7 years to enhance Canada's quantum footprint. Canada's quantum strategy is designed to amplify Canada's existing global leadership in quantum research and grow Canada's quantum technologies, companies, and talent. So we're going to kick off the discussion by asking our panelists what effects they have seen to date that the quantum strategy has brought on and opportunities that they see available linked to that strategy in Canada. So I'll ask a first volunteer to maybe give us their thoughts as we start the discussion today.
So why don't I start? We'll take the hammer to the ice and break it.
Thank you, Eric.
Uh, of course. So I think it's very important that this strategy is done, has been put out in the world, because we've seen on a number of occasions countries wanting to come and collaborate with Canada in a formal sense. And before there was a strategy, there was a certain blockage within the system about being able to effectively operationalize that. And I think Canada has this enormously positive reputation. I think one of the things to stress is that quantum is an area where Canada has, for the last 20 years plus years, invested and has done things right. And what we've seen, all of the people across the country here and others working on, is something that has been built over a long period of time. And the quantum strategy is about taking that to the next level. And what we've seen in the quantum universe is that it's gone from a research oriented occupation to one that is increasingly about applied technologies. We're not there yet in any fulsome sense, but having the strategy is something that will allow Canada to, in essence, make a transition to a marketplace. When you look at the numbers for the value of the quantum computing market, for example, it's about 235 million globally today. By 2028, they estimate that it will be $2 billion. And so the quantum strategy will be guiding the public sector participation in Canada's evolution in this particular market.
Thank you, Eric. Would anybody else be interested to add on these comments? I see Amy raise her hand.
I would agree with Eric there, especially his last comment there. I think having this national quantum strategy out is helping make all of government more coherent in this sense. For example, I'm today in the National Research Council, where there's been quantum labs for decades. Very nice. But now we're getting to a point where other departments who do not naturally have researchers, but are now becoming more aware and more engaged to be ready to adopt these future technologies as they come. At the government level, this is being enabled by an interdepartmental working group, and that's excellent to see, to bring folks more coherently together. And especially seeing this through the Quantum Research and Development Initiative that was funded in the National Quantum Strategy, to have government researchers start literally working together to solve some of these problems for different government departments. So that has been incredibly beneficial.
Okay, if I can build on that a bit. So I think that, the strategies, I think, to build on that, Amy has sort of brought forward these departmental strategies as well, right? So I think, kind of looking outside in on the government side, right, is this catalyst for D&D and DRDC to publish their departmental strategy, but also a detailed implementation plan with specific objectives and outcomes and dates, right? And we've added, that's been a great opportunity to leverage and participate with NRC on some of those activities that cross some of the departments. But from an organization perspective on the outside, right, I think we've seen a couple of sort of material things. One is we have seen funding sort of grow, not just in the, NSERC research funds, which has also grown, obviously, but these commercialization-centric programs, right? Amy's program in undersea quantum sensing, DRDC ideas, I think, have all received extra funding. And, a program that we like a lot is Innovative Solutions Canada. Like, I think there's probably been 20 quantum challenges over the last 12 months, and I can't imagine that would have happened in the absence of the strategy. And then finally, to build on the earlier conversation, right, internationally, and we've had a chance to go on 3 trade missions to Germany, UK, and San Francisco in the last 18 months. And there's one upcoming here in a few months to Korea, right? And all of that, I think, has facilitated sort of trying to foster that R&D and commercialization conversations between Canadian companies, Canadian researchers, and other companies and research institutes around the world.
Thank you, Nick. Andrea?
Yeah, if I may add to some of this. First of all, I also like to mention that I think it is a great success for Canada to have a strategy. That certainly, did not happen by accident. As was said, happened because of the big investments over the years, sustained over the years, into these kind of fields, a broad field of quantum science and technology, materials, all of that across Canada. There has been, I think, an important milestone, and has been the large investment that came with the Canada First Research Excellence program in 2015, during which 3 major investments were made across Canada: UBC, in our institute, Sherbrooke, Institut Quantique, and Waterloo. And so at that time, what was interesting to see is that these 3 centers, together with NRC, came together, stimulated by the government, by ISED, to rally the community and bring the community together. To me, that was very significant because, yes, there was large investment over the years. All of a sudden, there was a specific point in time when this investment was, really put Canada at the forefront of the field. But it was also an opportunity for the community to come together and fuel what is basically really a bottom-up type approach. And so that was followed by a number of meetings in Ottawa and other places where the community could come together: academia, government labs, and private sector. And I think for me, this has been, a key game changer for us. And I think this is reflected in the quantum strategy as it is being laid out, as an effort to bring together again these 3 pillars of the effort across Canada. So really, I think this is the strength of the strategy, is the government having looked at it, having realized what position we're really occupying globally, the leadership that we have, making sure the community is coming on board, and working towards a common goal. And so this has been complemented by a number of national initiatives, one being Quantum Days, the conference that's been now running for 3 times, again, bringing the whole community together. So big effort on the community part, together, synergistically with the government. So I think this is, to me, really extremely valuable and extremely promising for the future. So of course, now the key is to keep that going the same way. So keeping the breadth, the collegial effort, and a sustained funding, so to enable that. Thank you.
Thank you, Andrea. Sarah, would you like to chime in?
I don't have very much to add on top of all of that. I just wanted to maybe pick up on something Eric said at the very start there, which is that the strategy is important for connecting with other countries that are also pushing forward in this area, highlighting the strengths that we do have in Canada. We're a population small country relative to our neighbor to the south, for example, and many other big players in this field. But we have particular strengths. I'm in the materials sector, and I can see that part very well. But across the whole sector of quantum technologies, we do have the strength, and we've invested a lot in infrastructure through CFI, and also in intellectual capital through things like the CRCs, CERCs, and the CFREFs. And so to keep all of that going and show our strength on the international stage, I think it's been very important.
Thank you. So one theme that's come out is this international stage, international collaborations, which is tied to some level to the second question we had. As most of you have heard, in the last year, the Quantum Advisory Council was announced and is being led by Dr. Raymond Laflamme and Dr. Stephanie Simons. And just a few months ago, additional members of the council were announced, coming from industry, academia, non-for-profit, and the investment communities. So a very broad group of professionals. The question that I would have for the panel is, what do you see as the relationship between this advisory council, basically all these members now, and Canada's international collaborations, obviously existing, but also the potential for more of them in the coming years?
If you want, I'll start. I think that it's really fundamental to have the advisory panel because it brings that outside perspective. And you see this, for example, in the US National Quantum Initiative, where they set up a number of structures, an internal to government structure that advised on federal resources, and external to government structure, which brought in the views of academia and the private sector into the conversation. And having those views from the ground of people who are actually doing work on quantum materials, for example, is something that is extraordinarily important. And what this does is contribute to both a coherence of thought process around where things should go next, but it helps to contribute to Canada's reputation for excellence in this area internationally, because by having this feedback process, it makes everybody better. And that's something which is, I think, really important because, and I go back to something Andrea said, made me remember before there was a clear direction that we were going to have a national quantum strategy. You had major disagreements among government agencies, the NRC, universities about who would lead and it was the sense of who will tell somebody else what they need to do. And we got through that process through much dialogue and coordination. And this is about contributing to a collaborative approach, which makes Canada very, very strong in the quantum space.
Thank you, Eric. Anybody would like to add to those comments? Amy?
Just following on to that, I think this scientific quantum advisory council will especially be useful in this particular emerging tech where the hype is just insane right now. Like, what will a quantum computer be used for? What is quantum communications, quantum sensing right there to have a solid crew that can help it, advise government, no, that's not real. No, this is, despite it being on the news, that's to help cut through this hype to inform better policy making. Because policy making in emerging tech is hard.
Very, very much so. Anybody else would like to?
Yeah, if I may, or not sure, Nick is.
Go ahead, Andrea. I'll join after you. That's fine.
Thank you.
Hit the wrong button.
I'm both on. I'd like to echo both points here. I think there's the council can play a key role, has to play a key role. Breadth is crucial. I see strong representation of the council on the information computing, so really on the technology side. But I really think that the key role of the council, and I'm sure that we play that, will be to emphasize how important is the breadth of a research effort, in particular the fundamental research effort. So materials was mentioned, and of course materials as an enabled technology is at the foundation of all of the directions that we see specifically spelled out in the strategy. So I really hope that the council will be able to do that. And at the same time, though, when it comes to real application and translation potential, as Amy said, also identify, as time goes by, the most promising directions, and so keep the research focus while at the same time enabling the breadth to be there. So, and I think for the government, it is important to have a panel of experts that can speak to that. So that's really something I'm very happy to see.
And I'll just add to that, like, I think I kind of come from maybe a different perspective than just the pure research perspective. So I think having folks who have commercialization and investment experience, right, kind of looks at the whole picture on those international collaborations. And we've seen, I think every country has created every country or region has created a quantum industry type group, right? QEDC in the US, QUIC in Europe, QIC here in Ontario, right? And I think there's sort of the industry to industry sort of collaboration stories being built. I think obviously each government has its own policy area that have been talking between the ISEDs and its compatible organizations around the world. But I think having sort of a cross industry commercial venture group, I think, to help guide some of that, I think is useful, right? Because this is kind of a pretty big problem to solve between everything from starting with the research through the commercialization, and obviously the talent stream of making sure we have the right people to work on all these great ideas. So I think having a cross-functional team like that contributes to providing the right level of guidance to kind of move us forward.
Sarah?
I'll
just maybe add, it's a big job that they have on their hands. I would just maybe echo Amy's comment about cutting through the hype, which I think is really important at this time, where it's still really an emerging technology and there's a lot of potential, but also there may be some things that don't pan out. but also that group, because of their connections between industry and academia, have the potential to identify particular needs that industry has as well. So, coming from the materials perspective, we provide this foundation for technologies, but something that's very useful for us to do use-based research is to have those use cases being fed into us and say, hey, do you have something that can do this? And so they have the potential to make some of those connections as well, and help keep us connected to the end users of some of the research products that we have.
Thank you. So some very interesting thoughts, and you could tell that these council members are going to have their work cut out for them, and I think it's great that as we all know, they come from different parts of the ecosystem, which I think quantum is something that we're going to have to navigate as a country. As Canada, we hear comments like fundamental research, and then on the other hand, you hear about applied technologies, you hear about commercialization, and then hype, and then about talent. So there's a lot of work that the council has to think about. And this brings me to the next question. It's clear that the panelists even today come from different sectors of the economy, which is great and representative of what quantum is and the ecosystem we're working to build here in the country. So the Canada's quantum strategy obviously has impacted all of you in different ways. I would love to hear comments, and maybe Sarah, you can start for this one on maybe benefits or challenges that you've observed in either multi-sector or multinational collaborations where the strategy came into play in your experience.
Yeah, so I think maybe just building off that last comment that I made for the advisory council and their potential role, I think so this is a huge question in general for research, and collaboration, I think, is key and central to a lot of our work. Multi-sector is maybe a little bit different than a lot of our inter-academia collaborations, including international, because the interests are not always that well aligned. The interests are inherently different. As academics, we try to generate knowledge, and in industry, you're trying to generate a product that can be sold, right? Which is just the name of the game. And so that finding those connections is really important. But I think there's a huge opportunity here where we can do really interesting and impactful work if we can do the sort of use-based inspired basic research that is characterized by Pasteur's quadrant, if you think about sort of the axes of knowledge generation versus immediate use cases. And so I think given where we are in quantum technologies, that's kind of a good space to be in if we can really support that well. But it's a challenging space to work in also, because there's this risk that you end up sort of not doing either very well and kind of just tinkering and making small incremental progress. So I think if we can wrap our heads around that sort of high risk, long-term game and engage industry in it to bring those use cases forward and say, hey, we need new materials, we need new types of ways to address qubits. These kinds of things have basic fundamental science that needs to be done behind them, but that can then accelerate this industry forward. So that's, I think, one of the key things that the sector needs. And I've had some really great discussions around some Quantum Alliance Consortium proposals, and so I'm hoping that that's something that we can engage with. I can comment also on international, but maybe there's more to be said about this particular corner first, so I'll let other people speak.
Well, I was thinking, Nick, you mentioned earlier some international trade missions, and we're talking about the multinational collaborations that you've attended, and another one that's coming up. Maybe you'd want to build on that or mention what you see as how this could tie to the strategy.
Yeah, sure. So we kind of break the problem down into two sort of collaborations. One is, we set out to look for research institutes or research groups where we could collaborate on the fundamental research in support of the technology we're trying to develop. The other area is I would call commercialization collaborations, which is looking for typically large multinational corporations who might be interested in applying our technology to specific problems or market opportunities. So in the sort of former, the research area, to be honest, what we found, we go on the trips, we meet a lot of interesting people, but where it all starts is actually when the researcher to researcher has a good working relationship and collaboration. That becomes the foundation of the research collaboration, right? And those, I think we found it hard to develop those out of thin air in support of, say, a funding opportunity, right? Where it's like, hey, let's go work with the UK and find a partner in the UK and do something interesting. If there's no history there, it's a very difficult thing to sort of drive forward with. On the commercialization side, right, I think, in general, it's there's a lot of interest in quantum. I think, I'm not going to call it tire kicking. Well, maybe I will. But a lot of people want to understand where various quantum technologies are going to impact their business. But it's hard to find ones that are really going to seriously dedicate their researchers and their engineers to it, and put their own sort of product development funds on the table to do that work, right? And I think that they tend to look for government funding on some of those programs as well, right? And so we end up sort of collaborating with a large multinational, but using a government funding vehicle, maybe in their country, in our country, to fund some of it, right? And we've had some experience with that. We've also, just another one, right? We've had some experience working in a couple of DARPA programs with our organization. And that's been an interesting experience, right? Because that's kind of cross-academic, cross-company. We've been the general contractor for one of the programs. We've been a subcontractor to a big American company. So there's, you ask about challenges in that context. Paperwork is a challenge, right, on a lot of those, right? Paperwork, IP rules, different legal jurisdictions between different countries, all that stuff sort of comes into the mix of trying to put the actual program together and cement it.
Thank you. So one thing that I think stands out is when you mentioned that you need to establish a first relationship, and we know a lot of Canada's leading talent has studied abroad at some point in time or comes from abroad. So there's already, I guess, former classmates. You look at publications, a lot of them are done by multiple people at once. I was thinking maybe, Andrea, would you have any comments on some collaborations, how you would see those seeds getting started from that point on?
Yeah, no, definitely. I fully agree. I think is similar to how the all quantum strategy started as a bottom-up approach, of course, in sort of collaboration with the government. Here is the same. So we have here at UBC in QMI, in our institute, one of the, I think, very successful international collaborations for Canada is the Max Planck connection. So the Max Planck Society connection. So we have an international center of Max Planck Society. It's defined as a Max Planck UBC University of Tokyo Center, has been now renewed for 3 times. So a natural lifetime of the center would be 10 years. But we have gone beyond that because eventually from the research collaboration we had initially, now we also have a joint PhD program with University of Stuttgart and Max Planck Society. So it has grown into a big effort and is meant to be a sustained long-term effort. However, a situation like this really came about thanks to the existing collaboration between the researchers. So once again, bottom up, there was a lot of work that people did together across the ocean and in these 3 different institutions and countries. And this was eventually recognized and supported by UBC. And so that's really how things flourish. So I think every time we look at opportunities and opportunities for international collaboration, is extremely important. First of all, to have the support of the government, but at the same time, and so the funding agencies on both sides of the partnership, and at the same time, really looking for those gems which are already there and invest on those, so that those would be, the flagship. Those would be the activities that will then drive the effort and of course bring in other ones as well. So I think this is certainly something to keep in mind, but it's great to see that we have opportunities to do that now. Easier, still with some complexity on the administrative side and bureaucratic side, but certainly easier than in the past. So I think this is an effort that we'll have to grow and over time, but certainly there are it's very promising right now, I think. Maybe if I can add one thing before you were talking about challenges and so on in terms of the strategy and what do we see? I think this is I see maybe 2 of them. One is right now the strategy is framed in a way that is a very target, sort of very deliverable focus. Let's put it this way. It seems to be framed in a way which is very deliverable focus. However, at the same time, I do see that some of the fundamental research is coming in with a deliverable in mind, understanding, of course, that it may take more than 5 years, more than 7 years to get there, right? So somehow if we can keep that balance, that would be crucial, because the real impact is going to be in emerging technologies like this one in many decades from now. So we got to keep that in mind. So sure, having deliverables is important, because you're not just here for fun. We're here to achieve something. At the same time, having the flexibility of recognizing that some of the deliverables are ambitious and will require time. One particular thing, though, which I see as a challenge, and it's a challenge when we talk about academia industry engagement, or even when we talk about international partnership, is that right now, this effort, thanks to what has come in from the federal government and the provincial governments, and in some cases the institution, is supported by a group of unique individuals. These are the professional staff that different institutions, universities have. And so this is basically, these are, for instance, the people who run the nanofabs, the clean rooms, but also much bigger operation, the national facilities like Triumph, Canadian Light Source, Advanced Laser Light Source, and that Canada has. And these are the people, of course, that are going to train the students and the postdocs and keep the expertise and at the highest level internationally for the country as a whole, and the different pillars of the effort. And somehow there isn't quite yet a mechanism in the strategy to fund that and support that long term. So this is becomes a retention concern. These are a profession which in most cases have been trained in Canada, in some cases have been brought in from abroad. So really this is what you need to sort of overcome the brain drain and really start talking about the gain. And it's important we retain them long term. Right now, what we have is the federal level. The key program has perhaps been the Canada Foundation for Innovation, the MSI for large facilities. But as far as the quantum effort, there isn't a dedicated one. And in fact, we have seen that some of the emerging programs have not really received support in the last round. So that is a challenge. That I see as a challenge, because the National Quantum Strategy wants to fund more directly research and projects that can lead to deliverable. And this class of researchers we have in Canada, which really need, can already be funded through that. So this is where I would see that federal and provincial governments could come together to guarantee that support long term for that kind of workforce. An example of this kind would be, the whole effort in the US on the foundries, which is being put in place and which is now trying to be replicated here in Canada, but should also go beyond just foundry, more for the quantum technology and science across. So that to me is a standing out big challenge we have.
Thank you, Andrea. I think Amy and Eric have not commented on this question. Any thoughts to add?
Amy, do you want to start?
Sure, I'll start first. I think this has been mentioned already. The challenges of getting these agreements and paperwork in place. That has been a bit of a struggle there. My research program, the Quantum Sensors Challenge Program, is a collaborative program by nature. We collaborate with at least four countries of probably like 5 or 6 specific projects that have the collaborators in there. And exactly as been mentioned before, these folks have been found because they knew each other first, to Nick's point. Like there was some connections there already that kind of enabled that to start a bit. However, we also have tried some other things, such as joining an IRAP Innovate UK joint call. So IRAP paying the Canadian small medium enterprise and Innovate UK on the UK side, and QSP joining in on any relevant projects, useful projects there. And sometimes our programs don't align very well. And I think this is going to be a strength in the later half of the National Quantum Strategy, because many folks across many different programs and at higher levels are figuring out how to get these types of collaboration agreements in place. Once you do it once, you could use that as a template, or at least a starting point to do new things. So I think that the future is going to be brighter on the international side.
Thank you, Amy. Eric?
Yeah, so I do agree that the future is going to be brighter on the international side. I think a challenge is going to be to make things more substantive. So I did a piece, for example, on what Canada could reasonably do with the US on a number of fronts. And typically looking at the US agreements, and if you spend time working the US Canada domain, you find Canada does 95% of the work. So it's always on Canada to push, push, push. And the US agreement template has basically been, we both agree this is important. Maybe we should do something about it someday. And so rather than that, it's thinking through how do we get active programs of researchers that are actually going through the 5 national laboratory projects that are being developed and what the National Science Foundation is doing and things of that nature. So I think some thinking about how do we take statements of positive cooperation and turn them into substance in terms of people actually doing stuff on the ground. And certainly I take the Max Planck University of Tokyo collaboration that UBC has as inspiration for that. One thing that I would put as a challenge, I mean, maybe it's not a challenge as much as it's a preoccupation. And maybe you mentioned the hype, and there is a lot of hype about it. But we do know that quantum, on some level, is transitioning from an area that was very research heavy and commercialization light to an area that perhaps is a little bit more balanced in terms of the research and commercialization of it. And you've seen the development of great innovative companies in Canada. And I worry that as quantum becomes much more valuable, that we will have to think about what foreign investment rules look like in that particular area. How do you ensure that the ecosystem doesn't simply get bought out by an IBM or an AWS or somebody of that nature? And so we need to think about this now as companies are growing, and that goes to some thoughts on how IP needs to be managed, how the next rounds of funding need to be structured, and what we need to do to maybe not mandate, but at least incent that these companies stay much more rooted in Canada with their headquarters in Canada.
Thank you, Eric. Very insightful. The next question we wanted to bring to the panelists is, as we all know, the strategy is something that evolves over time, and it's a two-part question. I think that the first part is, if we look back at since the strategy, if you want, was announced or starting to get rolled out, do you have any takeaway lessons? As we know, a strategy can be amazing, but if it doesn't get implemented or executed as it was originally envisioned, you might get very different outcomes. So any takeaway lessons on the implementation of the strategy from where you sit? I think that could be useful to the rest of the people listening to the call as we think of the first years of this strategy and how it's unfolded.
I'm happy to take the first shot at that one. So I kind of build on my perspective of I guess maybe what's worked well, right? And I think we have seen funding, right, in new areas and programs for both research and commercialization. Mm-hmm. Like I said, lots of calls for prototypes, lots of activity in those areas, right? And also, I think most recently, even some programs in some maybe non-traditional, more end user communities, like the NGen Digital Cluster program that came out last week, right, of advanced quantum for manufacturing, right? So not just the core quantum research, not just commercialization of that research, but starting to look at where the other connections into the rest of the ecosystem are. I think aligning the government departments around a common sort of view that we're trying to do something significant here, I think has been really, really useful. And I think if you look over the last 3 to 5 years, maybe the last 3 years, right, there's been a fairly large and vibrant quantum startup community that's been sort of one of I think you can measure as one of the outputs, right? Lots of activity has led to lots of startups. Now, is anybody kind of, the question is who's going to grow into the level that gets to sustainable model, right? And I think Eric mentioned some of the challenges there, buyouts and things like that. A couple of further areas I would say the strategy could develop in terms of takeaway, right, is getting some more large Canadian businesses more directly involved in this, right? I think we'd love to see some of those big industries play maybe more of a role as end user. I would personally love to see like an innovative solutions program, linking up Canadian startups with big Canadian companies to be those first users. But I also, I think that has challenges based upon what I've heard before. But to me, that would be a great way to bring the Canadian big companies in as end users into this mix and leverage the strength of our economy.
Thank you, Nick. Anybody who would like to add to this on what they've seen as, I guess, the good and maybe not so good on the implementation of the strategy?
I just want to pick up on what Nick said. I mean, I was in a past life vice president for innovation at the Business Council of Canada, and so I think it's really important to work on getting those connections with large companies. By and large, we've seen the scores on R&D spending in Canada and the challenges on that front. So there does need, again, to be this cooperative sort of conversation with Business Council of Canada members, with the quantum community to get those use cases in effect, because otherwise you're likely going to see a lot of Canadian companies turning to particularly US companies, because you've seen, for example, Goldman Sachs and JP Morgan have hired heads of quantum because they think quantum will be very useful for future betting on derivatives markets, for example. So depending on what your area is going to be, there's a lot more private R&D funding available in the US. So developing a more formal relationship with large company organizations and getting funding that can be available to large companies to bring in small companies and apply those technologies, I think is going to be fundamental. We can't feel like it's going to happen on its own. It's something where, we need the matchmaker process that government and others in the quantum community can bring to bear in order to get those tools into the hands of the people who can use them.
Thank you, Eric. Anybody would like to add? Maybe Sarah or Andrea from the implementation, maybe more on the university or the academic side, which is obviously a key component of the overall strategy.
I was going to just take a different direction and talk a little bit about trainees. So coming from the university sector, we do. I know that it's a huge challenge to make sure we have the quantum workforce that we are going to need in the future. And there has been investment from the quantum strategy, but it's not been a huge investment. So there's been a few of the CREATE programs that were funded in the last round. And then no more quantum specific creates supported. And then very heavy leaning on MyTax, which is great for those very industry focused projects where students can spend some of that time actually working with a company. And I think it's a fantastic experience, but it's going to be only in a few areas where you can really have that good alignment between a student's project and the company's needs directly. Where that really works out and is very valuable for both parties. So it's a difficult matchmaking process again with sort of making sure that everybody is going in the right direction. I don't know the answer, the best way to support this. There could be direct funding for students, like scholarships and for students and postdocs that are working in the area. But there I think needs to be a little bit more support for that training environment and make sure that we're training that next workforce.
Thank you, Sarah. Andrea, did you want to?
Yeah, no, I fully agree. This is certainly where it was the same concern I had, and again connected to what I was saying before is the need to provide the best possible training environment when it comes to bringing talent in Canada. I think people come, especially the students, are first of all attracted if the universities are recognized as world leading in globally. And they are based on research. So fundamental research is what puts the university up there, and then what gives us the opportunity to bring the best possible students who then will become the workforce. And so in parallel with that, which I think is critical, is then also supporting that that scientific personnel that we have, the senior scientists, technical personnel, that not only enable the translation type effort, but also enable the training. So these are the two coming together. That to me is the one that in the strategy, the way it's being laid out, is not quite, maybe it could really receive more, especially because that would need to receive a bit of a longer term funding. So a longer vision, longer time vision for, to support these two kind of efforts, which is beyond what the strategy really is right now. So.
Thank you,
I
Andrea.
just to pick up on that again, is maybe what we need is to start identifying simple fundamental problems. So, for example, I do a bunch of work in the mining sector. The great dream in the mining sector would be quantum imaging, kind of LiDAR on steroids, because now in mining in Canada's got this whole critical mineral strategy and everything like that. You have to drill all these holes in the ground and wait a long time and test it. But there's been some speculative discussions about how can we use quantum imaging technology to better map mineralization. So you take a simple problem of how do we cut our time of being able to do our stated mineral reserves from 5 years to 18 months by using quantum technology. And then you kind of force these collaborations where people are doing imaging, and there could be sensing component, people in the universities to say, how do we solve this problem? And the universities get brought in to solving this fundamental problem. The graduate students get excited about the fact that they can contribute to something real. But what we're saying is basically, here's a real world problem. Let's find a way to solve it. And that way we're perhaps giving a little bit more direction, because again, we don't know where this is going to go, and you do have the height problem, but we do know that if we could solve certain fundamental problems with quantum technologies, that we could get to a good place.
Thank you, Eric. Amy, I think you were looking to share a few thoughts.
Yeah, just to follow up on that one in particular. Yeah, the way where the whole quantum sensing technology readiness level is, like, it definitely, it's not all at the area where, as Eric mentioned, we can all do that. We have some key fundamental research that's going to still be needed in order to propel the next generation of startups and technologies that can then move outward. But some of this stuff is happening now. Actually, almost exactly what Eric mentioned. We have a project with the University of Ottawa that's actually implementing some of these quantum sensing techniques to more quickly look at the component makeup of different ores here. But one of the things that we think has been a benefit of the implementation so far, of course, having that policy piece above, that's been enabling better collaboration intergovernmentally. Like for example, for our funding program, Quantum Sensors Challenge program is under the commercialization pillar of the National Quantum Strategy. And we've been able to work with other departments, agencies, and organizations, or at least start some serious conversations about how can we both have National Quantum Strategy money. How can we work together to make bigger, better, more impactful projects with all the different components along the way? Take the strengths of each of these types of programs and opportunities, and can we bring them together to create bigger things here? And hopefully our National Quantum Strategy road mapping, which is in progress right now, it's been great seeing the whole Canadian community gather together around that. I would like to hope in the future we'll be able to more coherently start addressing some of these real world adoption hopeful problems in the future.
Thank you, Amy, and I think a lot of the comments of you I've been listening. Most of them tend to fall under the main three pillars of the strategy, right? Whether research, talent, and commercialization, or subsets thereof, are key going forward. Now, and I think there's some great suggestions on things that could be done differently, or use cases that could help evolve. So the next question, I guess, and it's probably going to be our last ones before we open the floor to Q&A, is if we look forward from where we are today, what is it Canada can do to improve our competitiveness internationally going forward? What can we do or start thinking about doing so that 10 years from now, if we talk again, Canada is as or a lot more competitive on a global basis in this whole field of quantum? So I'll open it to the panelists. Love to hear your thoughts on the concrete actions that you think Canada can do to reach that objective. Sarah, go ahead.
I'm going to steal Andrea's talking point. So I think maintaining our intellectual capacity in Canada, making sure we keep the people that we've trained and the people that we brought here to build up all the strength that we have. And that's going to take a lot of broad-based support. So having support for fundamental research, that will make sure we have the training capacity to train the students that really want to go become entrepreneurs or work in industry. I think it's going to be critical to our future. And it will also make sure that we have the next technology in our pockets, that it's not somebody else developing it.
Thank you, Sarah. Anyone else has thoughts on what we can do to be in that leading position in 10 years from now?
So I'm going to maybe say something controversial, but I think eventually we might have to make some decisions on where we're going to pick our winners and double down on the things that are working the best. You know, I think that eventually is a tough decision, right? You know, politically, geographically, territorial, whatever, right? But I think eventually, we're not putting $50 billion into CHIPS Act in Canada, right? We have to think about what our investments are going to make a difference in, and what areas of this ecosystem we can, plant a global flag on, not just from the research side, but on the commercialization side. And I think that's an area that we have to think some more about, right? Like a lot of quantum sits at this Venn diagram of photonics, electronics, optics, MEMS, all these technologies kind of sit in the middle, right? And which of that do we think we really want to try and own on a global basis, right? And I think that goes to the talent that we have here, but also then some of the infrastructure and the capabilities that we want to build on, and where the funding flows to make that happen, right? So I think all that sort of comes together into something that we could do to pick an area to win in.
Andrea, we haven't heard from you in a while. Any thoughts?
Well, okay. First of all, Sarah did steal my talking point, so that was one. Now with Nick saying, I think Nick has the other side. So I think he's really finding that balance. That balance. In some cases, you have a path that really is going to lead to something, some very interesting and impactful applications in which we may have already a lead, and is going to be, high chance of success for Canada to go into and invest into. So that's a very important exercise. In parallel, though, I think it's really important to invest on, the technology of the future, which is not the one you're going to realize in 5 years. So it's really the curiosity driven and fundamental. So if you want to be successful in 2-3 decades from now, that is the kind of investment you have to make. And so I think one does not exclude the other. I think being smart and wise in terms of where you put your investment for the short term is critical. And you can be a little bit more dreamy when you go long term, but you have to keep both streams alive. And that's how you get that, that interaction between the two. And you have to keep that interaction going constantly, right? Because new opportunities may come up. And if you are ready, you can take advantage of it. So I would favor, really is what Sarah and Nick have done. If one can support those two sides of the effort in a coherent way, very quantum in nature. So that's the winning path, in my opinion.
Thank you. Amy?
I just want to echo a few of the thoughts here that we, in order to get to some of these big technologies that we want, there's still a lot of fundamental work to go to get some of these quantum technologies talking together, right? Like, it's great that we have this quantum computer here, in superconducting land, but like, how do we send that across the city, right? And how to get to quantum comms, to get this to photonics. So I think that's going to be something key to and those aren't the fun those aren't the the problems are that the tech that's going to be adopted. That's a key enabling component. We have a lot of enabling components and enabling tech in Canada for the quantum tech. And I think at the end of the day, we want systems that provide actual end user benefits. And that's something I've been seeing as a challenge in the quantum sensing domain. Components are cool, but systems are useful, and what big companies and other governmental departments want to be able to adopt there. Also to echo Sarah's point about, and it was brought up a few times, the talent I think is going to be a key challenge here, like the science policy problem of like the decade probably in Canada here, given the huge, really expensive housing costs. How are we able to bring students here and keep them here and keep them out of poverty and be able to work on this type of this they're the big brains here, the next generation of big brains. How do we have enough quantum staff for this in the future? That will be the question I see going forward.
Yeah.
Thank you.
So my sense on this is, number one, when you're thinking about what does the next 20 years look like, I guess part of the question is to ask, to what extent is what got you into a strong position in the first place what's going to carry you for the next 20 years? I think that Nick is ultimately right, that you're going to come to a point where you're going to make choices. I mean, my theory of the universe on this stuff is fundamentally we are hearing an awful lot about the race to build the quantum computer. But when I think about classical computers now, the value is not in the hardware as much as it's in the software. And so to me, if I'm thinking about where one makes investments, I think it's important to look at sensing and imaging as something that is really, really fundamental, because there's an awful lot of applications that can be used in those sort of applied technologies. If you look at the articles that are out there, quantum computing gets all of the bandwidth, but ultimately it's going to be how that capacity gets applied, how it gets turned into quantum communications that are secure. And then, of course, the other piece is, when does RSA get broken and do we enter into the whole world of needing to find secure cryptography in this new era? So, all of the services and perhaps non-obvious technologies, it could be where the value is over the long term. But I would always bet on software over hardware. And, of course, to get that, you're going to need the talent base. So the one part that is going to have to continue fundamentally is you're going to have to pour an awful lot of money into universities and research institutions in order to keep that talent pipeline fresh, because otherwise, it's like a plant that doesn't get water, it withers on the vine and then it kills everything else.
Thank you, Eric. As we're getting to the last minutes of the structured discussion before we open it to Q&A, just want to see if anybody had final thoughts on this question or some of the points we've covered in the last hour.
I would be remiss if in the talent discussion I didn't raise that one of the groups. I think the immigration is trying to work through some of these issues, but I think there's another level of maybe streamlining there that could happen, right, for the recruiting and of talent from other countries to come to Canada, right? We definitely struggle with that as a company, right, trying to bring people in, and I know there's different exemptions and things like that, but part of that talent is being attractive and easy for people to come here, right? And I think that's one of the things we can continue to work on as the next phase of the strategy. Like, I've been to some listening sessions with HHRDC, I forget the department, right? But on those topics, I think they're trying, but I think there's lots of things that could probably be evolved there to make it easier to bring high priority quantum talent into the country as well.
Thank you, Nick. So this brings us to 2 p.m. I'd like to take a moment to thank all of our panelists for this great discussion. We're not done yet. We're going to actually turn it to questions that you may have. I've noticed that in the chat, a few questions have been posed already. If people have other questions, feel free to put them in there. And I will take a moment to mention that CSBC will be launching a demographic poll shortly. So we would appreciate if you can fill it when it pops up on your Zoom application as we go through some of these questions. So let me, I've been looking at monitoring the chat, and we might not be able to answer all the questions, but obviously some questions are related to talent and opportunities for graduate students. I see that someone from MyTax has already provided some answers, and I think this covers, we just talked, the last comment about Nick was about immigration. I think all of the panelists have covered the importance of maintaining and growing the quantum talent, which is going to be key to the future. So maybe on this talent question. If I was a graduate student looking for an internship or to enter the quantum workforce or ecosystem, whether on the academic side, industrial side, research side, any thoughts or suggestions that the panelists may have for these students looking to start their careers? Sarah, go ahead.
Yeah, so I was just going to say, I think most of us in academia are happy to facilitate this as long as it meshes well with the students' research. So, from our perspective, we have to make sure students complete their studies and they write their thesis and they graduate. That's our piece of the puzzle. If there are opportunities where they can go and work in a company for a period of time and gain that different experience, that's so valuable for them as they develop as researchers and for their future career paths. About a decade ago, we had a CREATE program where we did this. We had students going, doing research exchanges and internships in both academic labs and companies. And it was so valuable. Those students came back and they were so motivated and they had gained so much from that experience. I think it's just a matter of finding the right matches to make sure that it really helps the student overall.
Thank you.
I can speak as an organization that did that, right? As a consumer of those kinds of recently, and we were quite successful. We had a student in her PhD before her thesis who wanted to get 4 to 6 months experience. And, thanks to Magtax and Reza, they funded it, which was great for us. And that student came back as a postdoc and will likely stay as a permanent employee, right? So that pipeline of experience, right? We love to help train people in kind of the applied side, the industrial side of research and the work that needs to be done there. And I think most companies, like I know, would be happy to kind of participate in those kinds of programs in the ecosystem. I know we are, and we're trying to expand our program in that area.
Thank you, Nick. Anybody looking to add to this?
I guess the one thing that I would say, Nick talked about the immigration paperwork. If you look at this comparatively, Canada is way easier than the US, for example. That's why if you go to downtown Vancouver, there's such a large, pretty office from Microsoft, for example, because they put people there who were on visas and they could get them into Canada. But the fact that you see a situation where it's relatively easier in Canada, A, it doesn't mean it's easy. And B, it's something where one constantly needs to be benchmarking how the system is working, and that technology experts and those who are going to study advanced technologies maybe are different than other types of people who maybe are coming into the country. So benchmarking the process of getting people in, getting them settled, figuring out where you're going to put the record numbers of international students for housing and other services. All that hands-on stuff are things that in the past, you would assume they just rent an apartment. Well, now there's no apartment to rent. So how are you going to make sure that they get a fully integrated experience so that they can focus on doing their studies and developing the next great ideas as opposed to worrying about where they're going to live?
Thank you, Eric. Another question that came in the chat and something we haven't covered, but that could be relevant is somebody mentioned international conferences, symposiums, workshops on quantum. There's more and more of these happening around the globe. I think the question is Canada planning to organize some of these, either driven more with an academic focus or industrial collaborations? And then any thoughts from the panelists here on what Canada should do on this? I know there was an IQT event held in Montreal in June. I'm sure there's been some academic collaborations, maybe sometimes with large or smaller attendance, but from a formal organization, should we be organizing more of these symposiums? In what format, and how should we approach this as under our national quantum strategy?
So maybe I could say something to that. I think is so maybe also in relation to the previous question, the two are sort of connected in a way. Quantum science is a huge field, right? So there are many different conferences that can address different aspects, and in fact, Canada is playing quite a leading role in many of those. And with many big international conferences having come to Canada or coming in the future. For instance, we held UBC, what is the largest conference internationally on superconductors a couple of years ago. And so in many other fields, there are similar situations. So for students, for instance, who are interested in coming close to this field, certainly I would encourage them to explore opportunities across the country through summer internships throughout the years, and really, again, exploring many different fields, because there isn't a single one that addresses it all. When it comes to a conference that speaks to quantum technology in a broader sense, I think at this stage for us, the Quantum Days is quite an important event because it brings the whole community together. Mm-hmm. And I think is very interesting. I know the feedback I got is very interesting for people coming from a specific, niche area to see the rest of the quantum landscape and ecosystem in Canada. So that certainly is one of interest. But yeah, so I think Canada is doing well. I'm sure that there will be more opportunities. There is a number of CREATE programs which will focus on quantum. So yet another opportunity to be part of those. There is the international quantum-related schools with the UK, with Germany in our case, and Max Planck and so on. By the way, there is also Max Planck International Center in Ottawa as well. So that partnership is not just Vancouver, it's becoming bigger. So yeah, there's quite a few opportunities. So I think I always recommend, exploring the different avenues when it comes to hands-on research, when it comes to conferences. Also there, explore the more focus on a specific topic as well as a broader one. And right now we do have one. It's happening again in a few months. So I would recommend the students to participate. It's interesting. There is interesting networking opportunities. There is poster session with great prizes. So please take advantage of that opportunity that we have right now.
Yes, Quantum Days is one that skipped my mind. I was mentioning some of the events, obviously a recurring one and an anchor. Any other thoughts on these existing events or new ones that we think could help on some of the pillars of quantum strategy, whether recruiting, retaining talent, or no? So I'll go to the chat and see.
Maybe.
Sorry,
I was going to, because I had one thing. There is also this opportunity about some, I think is more challenging, but for students who are interested let's say international collaborations that involve students also towards achieving a degree. So joint PhDs is one. We have one of those, but it's not the only one. So the idea of the co-supervision. The co-supervision could be bringing academia and private sector together. MITAX is one such example that favors that. The other one is a co-supervision within academic settings. I think that's a great opportunity in a field like quantum, which is multidisciplinary in nature. So I think that really adds value. So there are more and more of those opportunities. Some of the CREATE programs do have as a mandate the co-supervision concept. So I think that is certainly in an area like this, I would recommend, students interested at looking at these opportunities, I would recommend that because it allows you to have a broader view on the field. So at whether international or national level, the concept of working at the interface between two complementary sectors, I think is quite important.
Thank you, Andrea. Any other comments from our panelists on this topic? No. So I'll go to the next question, and it's a topic that came from a previous discussion. Use cases. There's a lot of people mentioned hype around quantum computing. Students that might be pondering a career in this field or starting in it. It may seem abstract to people that haven't been in quantum for many years. What could we see as short-term use cases? I know one thing that was mentioned was related to mining or geology on quantum sensing, and obviously quantum is much larger than Eric pointed out correctly, that quantum computing might tend to get a lot of the marketing bandwidth, if you want, but there's a lot more to quantum than just the computing side. So to help somebody understand, or based on your knowledge of the quantum industry, what would you view as a use case that could be relevant, value building for the Canadian quantum ecosystem, and ideally would be able to touch upon the quantum strategy? What could we expect, or do you think would be possible in the next few years? I'll ask someone. Maybe Nick, you can start
I'll
with this
start.
one. All right, Eric,
Nick,
perfect.
Go ahead, Eric, and then I'll
Yeah,
introduce my.
I mean, so, obviously the big caveat is we don't know what breakthroughs are going to come out of the great universities. So with all that in mind, where we sit now, I think we're going to see, I think precision chemistry is going to be an area that gets an awful lot of attention and focus, whether you're looking at how do you more efficiently build a battery that maximizes power usage by optimizing chemical interactions, and the same sort of ideas are being applied to precision medicine, and so to be able to make personalized medicines for people. Supply chain management is already something that we've seen, say, D-Wave roll out some tools in that particular area. So how do you optimally structure the movements of your on-floor robots in warehouses, the movement of containers at ports of entry, and things of that nature? That's going to be something that is going to be really important. And then the third piece, and I mentioned it briefly, is the use in financial services. So Michele Mosca's company just signed an arrangement or an agreement with the Bank of Canada to look at what does the digital Canadian dollar look like, and how do you deal with security issues around that. You've got the derivatives issue, and what that essentially will focus on is using quantum systems to more efficiently sort through the data to give you a better sense of how derivatives should be valued. And then, of course, the last piece will be the cybersecurity piece, because I think it's important to underscore that when Shor's algorithm is, when what has been seen is fully realized, and RSA and prime factorization as the basis of our computer security is no more, then you're going to be into this whole different world. And you see the National Institutes of Science and Technology in the US and others who are working on what they're calling post-quantum encryption. And this is part of what the Bank of Canada and others are interested in. But we're going to have to think about this, that at some point, somebody who we don't want to have done it is going to crack the fundamental basis of our computer security, and that we're going to have to transform how we are protecting our data and our networks very quickly. And there's going to be extraordinary demand for this, because once the systems are compromised, everybody's going to want to start protecting this all at once. And so for fundamental public and private institutions, it's about how do we start working on secure cryptography for the quantum era now, and start segregating what systems we want to prioritize protecting. Because when RSA is cracked, you're going to be in a whole new era, and the first thing that's going to happen is panic, and the second thing that's going to happen is action, and we need to know what we're going to do about it before we're actually having to do it.
Thank you, Eric. I think, Nick, you wanted to add on that?
Sure. So, yeah, so I'm not going to speak to the computing use cases as much. I'll kind of look at it through the lens of the work we're doing, right? And sort of looking at the whole sensing ecosystem and the opportunities, right? I think one thing to remember, right? Quantum sensing is not one market, right? It's 100 markets of products that might be made better through quantum, right? People buy magnetometers today, people buy gyroscopes today, people buy atomic clocks today, right? And fundamentally, I think there's hundreds of opportunities to improve those different use cases with the technology. So I think the opportunity is to identify the ones, I think Eric mentioned it earlier, right? The ones that are really hard problems to solve with the current kind of as is technology, and look at, can a quantum solution be better for those, the 2B of the quantum, to make a difference in those use cases, right? And my organization is pretty active in RF sensing, right? And we have definitely products emerging, right, in the next year or two in that space that are built around those quantum sensors. We see pathways to radar and communications using those quantum sensors. We're looking at navigation, be it gyroscopes and accelerometers and clocks as well. Right, so all those pieces are kind of in the wheelhouse of the things that we think can be products in a 3 to 5 year span of delivering value in the markets. And it's not a market you have to go find, right? There's $18 billion a year spent on inertial measurement units in the market today, right? If you build a better one, and better can be, have a bunch of different dimensions, but if you actually do build something that's better, there's a market there for that better technology, right? If it is better. And I think that's what I would encourage people to think about right on the sensing side, is there's lots of markets out there. And the opportunity is to kind of, find those use cases and turn the quantum 2B into something that's useful in those markets.
Sarah?
Maybe I'll add something to that. So I came up in my graduate studies through the nano craze. And one of the things that really jumped out to me was the ability for, I hope I don't insult anyone with this, the ability for failures in nano electronic devices to turn into fantastic sensors. So I think it just speaks to the ability to have your eyes open for use cases. So when you're doing fundamental research, we discover stuff all the time where we're like, I don't know if this is useful for anything, but if we know what's out there in terms of what people need, then we have the opportunity to highlight the things and find them when they come up. And so that was something that was, I think, really powerful in the nano sector. Actually, a lot of things didn't pan out the way we hoped they would, but they actually turned into really good sensors for a lot of different types of devices. The other thing that I was a bit surprised to hear from Eric was chemistry being one of the main applications. So I was going to say it, and then I was thinking, maybe it's a little niche. But not just in terms of computation, but also the way that we're developing our understanding of strongly coupled quantum systems, I think is going to change the way that we think about chemical reactions and designing chemical reactions. And that has a huge potential to transform pharmaceutical industries, energy sector, all of this stuff. So this is another, like sensors, it has a million different applications, but there's something there that if we can change the way that we think about how to design chemical reactions, there's a lot of potential for big impacts.
Thank you. Amy, Andrea, any thoughts on use cases that you have on your horizon?
All my speaking points, but I will persist on, that those are some great examples of some of the technologies there. I think like natural resources, as Eric mentioned earlier, is going to be some interesting way there. Can we take that magnetometer and use that for mineral sensing there? Can we quantum gravimeters? Hey, is that glacier is melting? How fast is it melting? How is the gravity? How are we able to measure that mass decreasing over time? There are some examples of stuff that we can do better with quantum enhanced technologies, and then there's some stuff that we can't do at all. For example, gravity measurements. We don't really do that classically. So that's some of the excitement of quantum, is there are some new ways of looking about it that could exist there. Another option, another general application or end use area would say it would be defense, safety, and security. For example, taking the RF sensing and beyond, visible and beyond there, that could be some really interesting areas there that could be useful. If you're sending single photons, that's beneath threshold. You can't tell. That's interesting stuff. And following up with, I think it was Sarah's point there, like the chemical detection. Can we functionalize some quantum dots or other things to be able to be sensitive to that molecule there, or try different ranging techniques that will absorb in certain bands for those particular things. So we're starting to merge together, but it's hard to bring it together, right? You got the science nerds pushing forward and where they think they know what the end use are. And then you like, and then we have the other side there, the industry end users who don't know anything about quantum, who are trying to push this direction. Like, how do we actually meet in the middle? I think that's where the magic comes. I think was it Nick who mentioned earlier, if we have the big companies like right in there seeing and watching some of this happen, be able to advise, no, we don't care about this problem. That's our actual problem. Can you tailor your application towards that? I think that's what we'll be needing going forward.
Andrew, we haven't heard from you on this. Anything to add, or?
A lot has been said. I just like to maybe emphasize how when you look at quantum science and the technology that comes from it, in some cases is okay, opening up new directions that you couldn't possibly imagine, because you really take advantage of some macroscopic quantum state that now all of a sudden can be exploited, can be utilized. That would be the case of, for instance, materials exhibiting quantum coherence at room temperature, ambient pressure. For instance, a room temperature superconductor that you could use to make qubits with, having to worry less about fault tolerant problems and decoherence. Then you don't need, developing your algorithm. That would be one case. And of course, that's what we try to work on, because that would be a major impact on the whole field. But on the other hand, you have all kinds of applications that are more in conventional technologies, now enabled by something, a material, an approach, a tool that was developed for a specific, quantum-related research project. So I think the mining is probably, as Eric mentioned before, is one of the most intriguing cases where imaging in various forms. We have colleagues here who have developed ultra-fast lasers for quantum spectroscopy, say, and now those same approaches can be used for more efficient, environmentally friendly mining. And yeah, that's quite remarkable how, you take one technology which is really developed, taking advantage of quantum phenomena and for purpose of doing quantum research, and now you're applying to a field that has huge impact. And so really there is a huge amount of a number of different cases that we see where this has an impact. And it's really that ability of, and I think Sarah was mentioning that, realizing, what are the needs, where that particular discovery or tool can be applied. And so having the crosstalk in the community, the constant communication is really critical to understand how you can match an opportunity with a need. So
perfect, thank you. So as we are answering this, talking about use cases, a question that just came through the chat that I thought could be relevant, and we're talking about Canada, and somebody mentioned use cases about the D-Wave. There's a participant that asked, what are the panelists' view on the future of quantum annealing? Anybody have thoughts on that?
So I know that in some ways this is controversial in certain quarters, and some people have views on it. My understanding is that annealing is going to have a place in the future, and it's going to be about what it tends to do best, which is process optimization. And so I don't think that we should think it's transitory and not going to have a place, but is it going to be necessarily the main event methodology? Probably not, but it is going to do what it does best, which is making complex processes run more optimally and efficiently.
I would agree with what Eric said there. I think generally speaking, in the quantum computing field, we're in the near intermediate scale quantum device era. We have lots of dreams of what we want to do with quantum computing, but the devices just aren't good enough yet. And, as Eric mentioned, there, that particular, algorithms that it can do, that those devices are optimized for, after we develop some more, we might be able to actually get business value out of these things. But computing is a long road to get there, and it'll be very fascinating to see how things evolve over the next 5 to 10 years in this field.
Perfect. So we have
Thank
just
you.
under 5 minutes left to the webinar. So I'd like to again thank our all panelists and maybe do a quick roundtable if you have final thoughts and as our time wraps up on the discussions we've had. Oh, and for those who haven't filled the feedback poll, it should pop up again on your window. Please please fill it as we collect these last thoughts. Andrea, did you want to start?
Oh, yeah, okay, I can start. I was going to say just a couple of words about the quantum computing, just saying that, still in relation to D-Wave, in fact, we have colleagues here working through a Quantum Alliance program, so a National Quantum Strategy funded program with D-Wave to benchmark what the D-Wave machine can do. So certainly, as Eric was saying, our range, different range of operations and problems that each machine can address. And so this is quite interesting to see our research is working with D-Wave towards that benchmarking. So maybe it's still early to answer some of these questions, but there is a lot of work, a lot of interest, and certainly is an interesting direction, even though, the purist of quantum computation would say a quantum annealer is not quite the same. As for, my final remarks, well, I go back to the usual talking points. So I think it's really important to keep the, when we think about a strategy, have in mind a long-term vision as to combine the, taking advantage of opportunities near term. We should really definitely do that, invest in that very strategically, but at the same time, aim for being, for the scientific excellence, the curiosity-driven research that would put us at the very forefront, not just in 5 years from now, but also in 10, 20 years from now. And in doing that, we are going to have the best chances of attracting the best researchers, of training the best workforce, and then the key will be that of retaining them. And so that long-term visions, funding for the fundamental research is key, and then the breadth of the research. So keep that in mind. Presumably, the completely new technology will really be enabled by new materials we don't have today. So quantum computing was one. I believe that really that would be a field that may have a real impact worldwide if we could find that material that really exhibit the long and robust coherence that we need for qubits. So I think the fundamental research there still plays a role. And that's all we need.
Thank you, Andrea. Anyone else have final thoughts as we wrap up the last 2 minutes? It sounds like no. So I'll take just a second to thank everyone for attending, thank our panelists for their valuable insight, and stay tuned for future conference events and check out the CSPC website and social media for details. Have a great day to everyone.
Thank you.
Thank you.
Thank you.
Bye-bye.
Bye.